Okay, so this is a short video to explain to you binomial expansion, which is one of the C2 topics. Okay, binomial expansion basically is looking at how you expand brackets such as over here we've got x plus 2y cubed, and over here on the right we've also got 2x minus 5 all to the power 4. And you need to have the skills to be able to expand those brackets and ones that are more complex than that. But we're going to look at these two examples and expand these first and establish those general principles that will help you to do more complicated questions. So let's have a look at this one first, x plus 2y cubed. Now, you could, with this one, it's relatively straightforward, you could actually do it based on the information, the understanding you had from GCSE, which is you expand each bracket and then obviously multiply the terms. So for example, with this one, you could do, well, one way you could do it is you could do this double expansion first, which would be x times x, which is x squared, 2y times x, so plus 2yx, and then you do x times 2y, which will give you another 2yx, and then you do 2y times 2y, which will give you 4y squared. You could collect those together, x squared plus 4yx plus 4y squared, and then you could times it by the last one, x plus 2y cubed. And you do the same, you do x times x, which will give you x cubed, you do x squared times 2y, which will give you 2yx squared, then you would do 4y times x, which will give you 4y x squared, and you would do then 4yx times 2y, which would give you 8y squared x, and you could keep going. But you can see even just with a simple one like this, it's getting quite complicated. So I want to show you another way of thinking about this. Okay, so what I can tell you is that when we expand this one, we know that we've got x times x times x, so we know there'll be an x cubed solution. The next one will be x times 2y. So one of those, we know that that would give you an x squared term. There would also then be an x times 2y, so we know there'd be a single x term. Lastly, 2y times 2y times 2y, there's no x's at all. So we could think about that in terms of powers like that. So what we're actually doing is we're starting to break this down and think about this in a tabular sort of way. So that deals with our x term. Okay, we've then got our 2y term. So we've got 2y term. Now, obviously if we do x times x, which is x to the power 3, there's no 2y in that, so that would be 2y to the 0. When we've then got two x's, so we have x times x, we have 2y to the 1. And there'll be a pattern coming up. When we have 1x, we do 1x times 2y, which give you 2y squared, and then lastly you'd have 2y cubed, which would be 2y times 2y, and there's no room for any x power. So we're starting to put together a structure that we can work to. And I think one of the things to note is whenever you're expanding here, you will note that the powers at any point always add up to the original power of 3. So this one here it would be 3. Here you've got 2y squared, and you've got 1x. So that adds up to 3 again. And that's a very important thing to remember. Now, we've got that, and we can start to expand these. So we've got x cubed, x squared, x to the 1, and x to the 0. Now, the thing that's interesting here is that x to the 0, let's get another colour. Okay, x to the 0 always equals 1. Let's expand out also what we've got here. So 2y to the 0, that equals 1. 2y to the power 1, that is 2y. Then we've got 2y all squared. 4y squared, 2y cubed, we've got 8y cubed. So we've expanded all of those. Let's expand these. Well, these are fairly straightforward. That's still x cubed. This is still x squared. This is, let's get rid of that out of the way. This is still x on its own. And then obviously x to the power 0 is 1. So we're beginning to put a table together that we will be able to ultimately use to map out what these expansions are. There's one more thing though. So we've got our x term, we've got our 2y term. But we also have to add to this is, and I haven't really given myself much space here, is the number of combinations. The number of different ways, what number of different ways can I get x cubed? Well, there's only one way you can do it. That's x times x times x. So that would be, there is only one possible way of doing that. Now, if we look at this one, how many different ways could we get x squared and 2y to the power 1? Well, that would be x in the first bracket, x in the second bracket, 2y from the third. Alternatively, it would be x times 2y times x, or it could be 2y times x times x. All of those will give you the same answer here. So this potentially would happen 3 different times, and you need to account for that. So we've got 3 possible number of times that would occur. If you do the same, there would be symmetry with this, there would also be 3 with this, and then there's only one way that 2y cubed can happen. So now what I've got is a table that we can now pull together for our expansions. Now remember, we're timesing everything together, so in this situation everything times together in the table as well. So we've got 1 times x cubed times 1. So that will give us x cubed. We've then got 3 times x squared times 2y. So that will be 3 times 2, which is 6x squared y. Next one, 3 times x times 4y squared. 3 times 4 is 12x y squared. And it's a plus. And then lastly at the end, 1 times 8y cubed plus 8y cubed. And that is an expansion of x plus 2y cubed, but using this table format you can actually make it a lot simpler than doing every single term, when it would obviously get quite complex and chances are you may well make a mistake. Now, the one thing I want to point out is this number of combinations, right, is driven by, or one way of finding those number of combinations, certainly for some of the more complicated examples, is to use something called Pascal's triangle. Very briefly, I'll draw it for you. It's basically the numbers below are the sum of the 2 numbers above. So once we've started off in this format, it's a lot easier to see. So here, 1 plus 1 makes 2. This side, obviously there's just one number on its own, so that's 1 and that's 1. There's always 1 on the outside, if you like. So the next one would be 1 plus 2, 3, 2 plus 1, 3, and then 1 on the edge. Then we do the next one. We've got 1 on the outside. 1 plus 3 is 4. 3 plus 3, 6, 4, 1. Now the key thing that we're looking at here is that, for example, in this cubic expansion, how many terms did we have? We had 1, 2, 3, 4 different terms. So this would be, what you'll notice, that this one here, 1, 3, 3, 1, that relates to the x cubed that we did. 1, 3, 3, 1. This one would relate to an x to the power 4, or something where you were doing something to the power 4 expansion. Very simple. The reasons would be is if you were writing your table, we'd have x to the power 4, but then we have to remember we always have x to the power 0 at the end, and that will make a little bit more sense when we look at the next example. So when you have something to the power 3, you have 4 terms. When you have something to the power 4, you have 5 terms, and it's important that you remember that. Okay, So we could use Pascal's triangle to help us identify the number of combinations. We will talk more about that next in the lesson, but it gives you a starter to do this expansion. Okay, so now we're going to do a slightly more complex example, which is this one here, 2x to the minus 5 to the power 4. So we have 3 rows, so this is a chance for me to write it down a little bit more clearly from all the work that we did before. So what we've got our combinations, we've got our 2x term, and we've got our minus 5 term. Okay, so those are the ones we've got. And what have we got? We've got all the way to the side of the board, which is good. So here we would start off with 2x to the 4. We'd have 2x to the 3, 2x squared, 2x to the 1, and 2x to the power 0. So that's the first thing that we've got. And the minus 5 would work in reverse, because obviously if that's the power 4, this would be minus 5 to the power 0, minus 5 to the power 1, because obviously 3 plus 1 makes 4, minus 5 squared, minus 5 cubed, and minus 5 to the power 4. Okay, so we've got those two, and we can start to write in our conclusions if you like. So 2x to the 4, that would be 16x to the power 4. 2x cubed is 8x cubed. 2x squared is 4x squared. 2x to the 1, and then obviously anything to the power 0 is always 1. We can do the same underneath. Minus 5 to the power 0 is always 1. Minus 5 to the power 1 is minus 5. Minus 5 squared, 25. Okay, then we've got timesing by minus 5 again. Careful, minus 5 cubed is minus 125. And then if we times that through again, you should get, so minus 125 times by 5, 625. Now the key thing here, that minus, when you've got that, that becomes a plus, because you've got minus 5 times minus 5 times minus 5 times minus 5. 5 times 5 times 5 times 5 is 625. Minus and a minus makes a plus. The odd number of powers makes a minus, but the even number of powers makes a plus again, because they cancel each other out. Okay, so we've got that. Now, what we also need is the number of possible ways that you could do the different combinations. So, how many different ways could you do 3 lots of 2x and 1 lot of minus 5? This comes back to our Pascal's triangle. Now, how many terms have we got? 1, 2, 3, 4, 5. We need to use the one that's got 5 terms. 1, 2, 3, 4, 5. So I need to use 1, 4, 6, 4, and 1. Okay, so now we've got our terms, we can start to pull it together and multiply it out. Now, I'm just going to get my calculator. Okay, so obviously in C2 you can use a calculator, and that's absolutely fine. So what have we got? We've got 1 times 16 times 1. That I think I can do myself. That is 16x to the 4. We've then got 4 times 8 times minus 5. Well, 4 times 5 is 20, times by 8 is 160. Don't forget your minus sign. Minus 160x cubed. We've then got the next one, which is 6 times 4x squared times 25. So 4 times 25 is 100, times by 6 is 600x squared, and it's a plus. The next one is 4 times, just to make sure, I want to make sure that you are seeing the bottom part, let's just make sure it's perfectly clear. So we've got 16x to the 4 minus 160x cubed plus 600x squared. That's how far we've got so far. And we're doing this one here. So we're doing the 2x one. So we're doing 4 times 2x times minus 125. Well, 2 times 125 is 150. Times by 4 is 600. Don't forget your minus sign. And then the last one is 1 times 625. And there is the expansion for 2x to the minus 5, 2x minus 5, all to the power 4. So, I hope that makes sense. Please do have a go at the questions that you've been set, and we can talk more about Pascal's triangle and doing more complex questions in the lesson. Thank you very much.